Welcome in, my Microsoft Massive developers, architects, engineers, enthusiasts. We who are about to code salute you. We've got a great show for you today where we'll be demystifying transitive routing in Azure. But before we get going, a message. A lot of subscribers have been asking me what software I use for my presentations. The quick and easy answer is that it's software that we built here at ThinkMind called Scribecast. We'll be publishing it to the Windows Store very soon, and then you'll be able to get your hands on it and play around. Send me an email if you'd like to be a part of the beta program and get your hands on the bits. Now, onto the video. So I'm going to start out this tutorial with a definition. What do we mean by transitive routing? So in general, in Azure, if you've watched my previous video, we have this notion of a network. And within the network, you would have subnets, which are essentially breakups of that network. And in Azure, you can have multiple of this. We call networks for short VNETs. And you could have multiple of these VNETs with multiple subnets inside of them. Right? So this would be VNet 1 and this would be VNet 2. And you can create these VNets, and inside of these VNets, you can add appliances or services. You could have a website, add another website here, add an app service here, add a Azure function here, pretty much you name it. And then, of course, there's also the parts of the Microsoft network that are outside of your own private networks. This all sit inside of your own private network. And then there's also a public side of it that's controlled completely by Microsoft, that essentially everybody who uses Azure is inside of when they are creating app services, when they're creating Azure functions, logic apps, pretty much everything. You're somewhere inside of here in one of these networks, and Microsoft controls how they move you around. So we're not so much worried about this side of it. Now, one of the things that you can do with VNets is that you can peer them. So peering them is basically creates a link between virtual networks. And when you do something like this, by default, if you were to try to communicate from here to here, it won't work, because by default, your services, your devices, your resources that you have inside of a given network are local to that network. Now, they can talk to each other. So I can talk here, and I can talk here if I so desire, or even back the other way. I can talk here. I can talk here. You can pretty much talk to any subnet inside of your VNet by default. But what happens if you have a resource here and you want to communicate with a resource? Change the color. What happens if you have a resource here and you want to communicate with a resource here? How do you do that? Well, that's where this peering comes in. To do that, you would create a peer relationship between these two subnets, between these two VNets. And then I can then communicate via this peer relationship. And it allows me to talk to resources in separate VNets. So what's the value proposition of this? Why does this even matter? Different resources may have different security profiles associated with them. You might have a network here, and this network is, let me change the color there. You might have a network here, and this network I'm going to depict as red. This network is red because it's got all the resources inside of it are basically exposed to the public internet, right? Or you have lower security profiles on them. You might things in this network you might allow, like if you had a server in here, you might allow it to go out to the cloud to download things, which could be a security risk potentially, because if someone downloads something that's malicious, then obviously it'll compromise your network. You might have a server in here that serves as a firewall. And so you allow traffic to basically come in, and then that traffic is then filtered and not exposed to what's inside. And then what you have inside is you now have your private network. And in here, you may have things like your database, right? So this guy communicates with that. You might have underlying servers in here that do some work. And this subnet may actually be connected to your on-prem environment. So it actually goes into what's happening in your local environment, and you might actually have computers sitting in here that get to resources here through a relationship that starts down here. So when I request a server up here, it passes through here, goes all the way up, and goes out here. When a request comes in this way, it never has any access to this. The only way to access this is to go here. And when you go here, then this guy serves as a broker and sends messages down into your private network. Let's say you had a VNet A and you have a VNet B, and then you have a VNet C. With Azure, I can peer this VNet, and I can also peer this VNet. That means that if I have a resource in here, it can communicate over here. And if I have a resource in here, it can communicate in here. So this guy can go in this way, and this guy can go in this way. They can both get to it. And on top of that, this guy can also get here. And this guy can also get here. But what about going from VNet A to VNet C? What about this or this? So in Azure, this is actually not allowed. This won't work. This won't work. You cannot, if just because I peer VNet A to VNet B and I peer VNet C to VNet B, does not mean that VNet A can now request resources in VNet C. Now that is how Azure is set up by default. But in this video, what we're going to be showing you is how you can circumvent that and still be able to create these kinds of relationships. Basically, we're going to be showing you how you'll be able to do this conceptually. You're not going to be doing it directly like how you have it here. What you're actually going to be doing is you're going to be setting up essentially a proxy in here. And then when this resource requests something, let's get rid of some of these guys. When this resource requests something over there, instead of it going up like that, it's actually going to go through this channel over here. It's going to end up hitting this resource. And then this resource is then going to have the wherewithal to forward it to its final destination. And then you can do this in either direction. So A bounces to B and then ends up at C. And C, instead of going direct, bounces through A and then bounces through B and then ends up at A, right? And over here. And the secret to this is a capability that exists here that we're going to be talking about. So what we're going to be showing in this video is we're going to be showing a cheap way of doing this and a sort of expensive way of doing it. We're going to do it using the servers that you already have available in your enterprise. No need for anything special to be able to create this capability. And then we're also going to be showing how to do it using an actual feature in Azure that allows you to do transitive routes. Now, as a baseline, we're first going to create the virtual networks. We're going to peer the networks. We're going to create VMs and put them in the networks. And then we're going to create something called a Bastion host. A Bastion host is basically a mechanism that allows you to communicate with VMs that are inside of your private network in a secure manner. By default, when you create a virtual machine, you can provide a public IP address to it. But if you provide a public IP address to it, then obviously anybody who has access to that public IP will try to access that server, and that's something that you might not want. So what you can do is you can create these bastions, and it allows you to communicate with the server over an HTTP channel. You go in a web browser, and from the web browser you can control the server. You don't have to use RDP client to do that. Now, in the cheap way, we're going to be setting up IP forwarding in the registry for one of the servers. We're going to then enable port forwarding on that server. We're going to create UDRs, which are user-defined routes, and we'll talk a little bit about what they are, that point to that server. That server is essentially going to serve the function of something called a network virtual appliance, or NVA. So we're going to do that, and then we will do a ping test and trace route to ensure that everything is all working properly. Once that's done, we'll go the pricey route, and I'll now show you how to set up Azure Firewall. Then you'll add some any rules to Azure Firewall. We will update the user-defined routes that we create so that they point to the firewall as opposed to pointing to the MVA, or the server that basically serves to broker messages from one virtual network to another. And then finally, we'll do another ping test and trace route to ensure that everything is connected and properly working using this new approach. So with that said, let's get going. Before we get into the actual doing of things, I just wanted to point out some of the value that you get from being able to create transitive routes. And I'm not going to go into the full network details, but in general, we've already talked about the fact that with a transitive route, you can create VNET, so V1, V2, V3, and you can set it up so that essentially the communication between V1 and V3 doesn't exist anymore. Normally, if I had something in here and I wanted to talk to something in here, I would have to create another parent relationship. So I'd have to create another parent relationship with this in order for them to be able to talk to each other. As you start having multiple networks all over the place doing different things for different purposes, you basically end up with a little bit of spaghetti stuff where everybody's connected to everyone. Everyone needs to know how to talk to everyone, and then managing all these relationships. Even right here, 1, 2, 3, 4, 5, 6 different peering relationships, being able to manage them and know what they're connected to, what they're not connected to, how you can route them, and with it increasing with each additional resource, like if I add another one here, then everybody's going to have to connect with that somehow. It can get very, very messy, and it's something that you want to avoid. One way around that is to basically set up what's called a hub and spoke. So what you would then do is you have a hub. This would be like a central VNet. So let's call it VH. And then you'll have your spokes. These would be all the various VNets that we saw, that we were just looking at before. They all connect to the hub. So they all have direct relationships with the hub, but they don't connect with each other. So what this does for you, right? So this is V1, V2, V3, V4, and V5. What this does for you is that you now don't have to manage these relationships over here that you don't really care about. I don't care about these, so I don't have to manage any of these. They don't matter because they can't actually directly talk to each other. That's one benefit. But the real big benefit is that you now have a single place where you can control how the kinds of interactions that you want. So conceptually, you could still create something similar to this right here, right? As we saw in the first video, you could still create that, but you don't create it directly by connecting them to each other. You create it by inside of here having this broker or this proxy, and then have this guy control connections. So when you make a request in here, I'm going to set some kind of policy, right, that I will use to determine who who he's allowed to communicate to, who he's allowed to communicate to, who he's allowed to communicate to, this guy, this guy. It's all controlled from this one location where we can better rationalize and understand what's going on. If we need to stop any communication from happening, we don't have to go finding where all those things connect. All of that is all right here. And all we have to do is remove an entry. And once we remove that entry, then you're no longer able to talk. It's really that simple. So that's one huge advantage that you get from being able to do transient routing, because now I can easily route that way with no problem, or I can route this way with no problem. And it's all being controlled by this policy and this resource in here. Again, a network virtual appliance, or NVA, that handles and brokers all the communication between the various networks and resources in the networks that need to connect. That's one important thing that you get from it. Another we saw earlier already, and that's this notion of setting up enclaves. An enclave is basically a portion of your network that is highly restrictive to get into. So if you used to build websites before, you might have heard of this notion of a DMZ, right? DMZ, which stands for demilitarized zone. So this is an area where people can come into your network. And typically the way it would work is that you would have the internet, and traffic would come in through the internet. And there would be some area here. And, I'll draw it in red so it's clear. There'll be some area here. And inside of this area, you would have these servers. And the servers could be anything that you want the internet to be able to access, right? So you might have a firewall, you might have an FTP server, and I don't know, something else, some kind of server that does something in the outside world. And then in here, so this is your DMZ, and then in here, this part is basically private. So the job of this firewall right here is to make sure that requests coming in only come in the way that is controlled by you as the enterprise. So a request might come in, and it's going to be filtered through that same policy file that we just showed there to make sure that it's as it should be. You might have a policy that says that only HTTP requests coming on port 80, or HTTPS requests coming on port 443 are allowed to come in. So if I were to try to make a request, a ping or something like that, it would not go through. Now in here, what you would then have is you would have your actual web server, which basically services this request and returns the result to the end user. Now, what can be immediately available to you from this diagram as well is that from the perspective of the end user, so some guy on their computer over here or their laptop, from their perspective, when they go to www.something.so.com or something.com, it's going to resolve to this guy right here. From the perspective of this user here, this does not exist. They have no visibility into what's happening behind the firewall. They have no visibility into your internal network. So you can also use this technique to build these kinds of architectures and essentially abstract away your internal network from the external world. And you can see how easily we could use this technique as well to do that, right? We only need to put this in its own VNet and put this in its own VNet, and then we might have another VNet here that serves as the proxy between the two. So we don't even ever expose that. And in here, we basically have our MVA, and traffic goes this way and then goes this way. So these two networks have no connection to each other. They are not connected in any way. And if this network becomes compromised, if something happens in here, it will be hard for this person that's in here to actually be able to know where to go to in here, because all of these are private networks, private IP addresses, difficult to really understand and rationalize what's happening here and how traffic needs to be processed for it to get in here. Right? So that's the huge advantage. So let's go ahead and let's get going now that we have a basic fundamental understanding of what we're trying to do. So the first thing we need to do is create a resource group where we're going to host all the components for our application. So I'm going to go and create it, and we'll call it demonstrations transitive. It's a good enough name. I'm going to keep it in the East US. And let's go ahead and create it. There we go. Now we can go into it. And let's go ahead and let's start creating our resources. So we're going to follow the model that we did before and basically create a VNet A, a VNet B, and a VNet C. So we're just going to call this VNet A, keep it in East. We're going to enable a Bastion here. And so when you check this right here, when you specify that you would like to enable a Bastion, I'm actually going to use green since it's Azure. When you specify that you're going to enable a Bastion, you'll see that you'll have to give the Bastion a host name. Remember that we talked about this in our previous video. If you haven't seen the video about app services, right now app services are essentially VMs. The compute boils down to an actual machine. So this is asking for what do you want to call that quote unquote machine that's going to serve as your Bastion host. Now, it doesn't have to be a physical machine, it can be a virtual machine, but it's essentially a machine that allows you to broker communication into your environment without having to use RDP. So it's much safer. The other thing you'll notice is that the Bastion host expects a public IP address to be associated with it. This is because, of course, for this to all work, it does you do have to be able to access it from the internet. So what you're specifying is the actual IP that you're going to be using to access it over the internet. We're not going to be setting up a firewall or anything for that. Now, what's happening here is that for this virtual network, you need to pick the IP address that you want the network to use. So I'm going to be using 0.5 here. So I'm just going to set that to 0.5. Because we're actually going to be using a Bastion, Bastions require some special subnet to be configured inside of your network in order to support that. So typically, how this all functions is that you're going to say, hey, I want this to be my Bastion, where my Bastion is located. And so Microsoft, when they're creating this subnet, they are actually going to go ahead and add the capabilities to the subnet in here. So this is the Bastion host. And it doesn't just have to be one, it could be several of them. It could be clustered. Think app service plan and server farm. They add the ability for you to create a server farm that's going to represent your Bastion. And ultimately, this server farm, if I can blow it out, this server farm is going to look something like this. You have some kind of front end IP, and then that is essentially some type of load balancer. And behind that load balancer, you'll have these hosts, which could obviously be VMs or physical machines. It doesn't matter how they're actually realized. Ultimately, these hosts will represent a machine that you can connect to that is inside of your network. Because remember that your network, anything in your network can communicate with anything else in the subnet in your network. So they can all talk to each other by default. So one of these machines, now when you set it up, it will basically allow that machine to talk to the actual machine that you've configured. So this is your actual machine, and our Bastion will actually be able to communicate with it. Okay, let's get back to it. So we've now created the two subnets that we need. These are the subnets that are going to serve our application. This is where all our VNets are going to be put into. And this is where the Bastion host is going to be located that can communicate to that. So we can review and create it. Okay, so that's done creating. So let's go ahead and let's create the next virtual network. This would be VNet B, and everything here should be the same now. Now, one interesting thing is that on VNet B, we're not going to specify a Bastion host. Now, why are we not specifying a Bastion host? Again, remember that we have the network set up such that we have A, we have B, and we have C. A can communicate with B, C can communicate with B. That's the way it's set up. And we have a Bastion host inside of A. We're going to set one up. And we also have a Bastion host inside of C. With the Bastion host from the internet, I can access A through this Bastion host. I can access anything inside of A through this Bastion host. So this is my server, this is my actual server, and here's another server. And the same thing, I can also access this Bastion host. Now, what do you notice here? Well, if I have access to the Bastion host and I can get to this computer right here, if I can get here, a little bit darker, if I can get here and I can get here, then from here, I can use the same technique. I can use the same Bastion host technique, and I can open up an RDP session. And from that RDP session, I can get here. From this RDP session, I can also get here. I can pick and choose. So you don't necessarily need to have a Bastion host configured here, because once you're on this computer, once you get here, from here, you can access any other computer using RDP that this computer has access to. And this computer right here just happens to be a computer that they can connect to via the peered link. And the same thing this way. So because of that, we can save ourselves the cost of one additional Bastion, because these do cost money. Just configure one up here and then just essentially use that to connect in here. Okay, so we can go next. And we're going to see that we have to do the same thing here. This time we're going to use just 6. Make sure you switch it to a 24. 24 is 256 addresses. And we just need to modify it here as well. The tooling does not modify it when you make that change. And we need to make sure that that's a 28, which would be 16 addresses, 2 to the 4. And then we can just create it. And now we can do our last one, which is VNET C. So let's put it in the same resource group. And again, because we need to access it, we're going to create a Bastion host. And this time, the first time I just used the default, but this time I'm actually going to change the name so that it's clear that this is an IP address. It's an important convention to usually indicate via the name what a resource is. And that's all set up for 7. So I just create that. And we are all set. So we can see that we have the resources that we need created now. So let's go ahead and let's peer these resources to each other. Again, peering allows for one network to be able to communicate with another. And there are some important things to note here. One of them is this pairing right here. Let me make this a little bit smaller. Rid of that and change it to green. So this pairing right here, these 2 items, and there's another 2 down here that are important. These other ones are important as well, but we're not going to go into details of them. These 2 are become very important when you are trying to communicate between your on-prem environment and your cloud environment. But for now, for this demo, they're not going to be important. But these ones are. So the first one is allow VNet A to access peered virtual network. Of course, we know we want that. That's what peering means. It connects them together. The second one is allow VNet A to receive forwarded traffic from the peered network. That means that that if VNet B, which I'm going to be peering to, sends a message to VNet A that was forwarded, it did not come from VNet B. It came from another network, but VNet B forwarded it on because it wasn't in that network. If you don't check this, it will not allow that. And the same thing applies between VNet A and the other VNet that we're going to be communicating with, which is VNet B. You need to allow for them to be able to communicate with each other, and you need to allow for them to be able to forward messages to each other. Again, it's that forwarding technique that we're taking advantage of. Because we don't want to do that, we actually want to do this, and then from here we want to do that, and then vice versa. We want to first do this, and then from here we want to do that. This piece right here, this piece right here, and this piece right here, that's called forwarding. So this is just the connection between A and B. And then we're also going to do a connection from B to A. And we're going to pick the network we want that we're connecting to. We're connecting to B. And of course, we're going to allow them to do the forwarding of traffic. And just looking quickly. Now we're going to do the same thing with VNet C. We got C to B, and then B to C is what we're going to be connecting it to. And of course, we're going to be connecting to B. So they both are connecting to B. And we want to allow B to be able to forward traffic. And then VNet B, we can go in here and we can see, let's refresh it. It's not showing everything. There you go. So when you actually do this, it adds both of those together. So they're both there. So when you were configuring the other end, remember when we're doing A to B, we configured A and B. Then B to C to B, we configured B and C. The flip side of it was B to A and B to C, those communications. So when you're doing the peering, you're configuring both sides. So if I configure this one, then I also have to configure this one. If I configure this one, then I also have to configure this one. There's no one-sided peering. If you peer one, it peers the other. So what you end up with on this end is you end up with two connections. You have a connection down here, and you have a connection up here. So now that we have the virtual networks peered, let's go ahead and let's create the virtual machines that are going to sit inside of the networks. So this is essentially the Windows server that's going to be sitting inside the network. So we're going to create, let's go through the process, create it right here. We want to give it a name, so we just call it VMA. Keep it in the same thing. We don't want infrastructure. We don't want any availability zones. We're just going to use a standard security. We're not doing Ubuntu. We're going to be doing Windows. And then we just give it credentials for accessing it. Allow for RDP to communicate. So let's now go over to the networking where there's nothing for us here on the disk side. So on the networking side, we do not want a NIC security group. We don't want a public IP address, and we definitely want, when the VM is deleted, to delete the NIC associated with it. There's pretty much nothing else in management and advanced. For what we're doing right now, I mean, I would implore you to look at these before we're doing right now. We don't need to touch any of these. And that gives you a general sense of the cost right there of the resource. Comes up to about $150 for this particular one. So that's created. So let's now go ahead and create another VM. This one is going to be VMB. Let's put it in the same resource group. No, once again, no availability. Set the credentials. And again, we're going to connect it to VNet B. We don't want a public IP. We don't want that. And we're pretty much all set. Right, so we're done now. And I'm going to show you a quick shortcut. So you notice that they have this button over here that says goes to resource. Well, what's next to it is a button that says basically create another VM. So when you click on that, when you're creating lots of VMs, instead of bouncing back and forth all over the place, going all the way here to look at the list and then create it from there, just click this button right here. Let's go ahead and let's click it. And we are here. VMC, no availability zones. And we're just entering our credentials. And we're putting this in VNet C. And once again, we're going to have no NIC security group. We're going to delete it when it's done, and we're not going to have public IP. Let's create that. So it looks like that's done, and we have all our VMs created. So why don't we go ahead and let's actually connect to this VM. So we'll start with VMA. We're going to use the Bastion. So we're going to use ThinkMine, enter our password. All right, so let's go ahead and let's create a connection to VNet B. And then finally, we'll create a connection to VNet C. So one thing that I want you to remember is that this is a demonstration. We're doing this for demonstration purposes. We're going to be doing some things now that we have the VM set up that I would strongly advise not to do. For example, we're going to turn off firewalls just so it's easy for us to see the different servers communicating with each other. In a real world scenario, you obviously would not do that. We start by going to Windows Defender on VMA, and we're just going to disable public um, private access. We're eventually going to disable public access as well. But for now, I just want to show you how this all works. And we're going to go to VNet B, and we're going to do the same thing. Turn off private. Now we go to VNet C, and we can also disable that. Now we can open PowerShell up, and we can start doing our testing. So I'm just opening it in each of the VMs so that we have our environment set up. Now let's look at what the IP address of each one of these is, what's actually registered as the IP address. So we have 6.4, we have 5.4, 6.4, and this should be 7.4. So basically, we have precisely what we wanted to set up now. We have 3 VNets. We have A, we have B, and we have C. And inside of each, we have a machine. That's VMC, VMB, and VMA all set up. And in there, we've got our PowerShell set up, and then we've disabled the firewall so that they can't talk to each other. And we now know that this is 10.0.5.4. This is 10.0.6.4. And this is 10.0.7.4. They don't have the ability to communicate with each other, except that these two guys can communicate and these two guys can also communicate. This is how we have this set up at the moment. This is what we're working with right now. So let's try pinging the actual VNet. As you can see, the request is timing out. Why is it doing that? Look at our peerings. course, we first of all want to allow the forwarded traffic, even though that's doesn't apply right now. We're just going back and adding it because that's actually needed. And in here, we'll also check that because that absolutely is needed to forward the traffic. So the reason this is happening is because we also have to disable this. Now, in a real world scenario, once again, you're not going to be disabling that. But we disable it here because what you would do in a real world scenario is you would go into this actual public access route and you would make sure that whatever traffic you're trying to pass through, in this case, ping is ICMP. So you'd make sure that that was enabled so that you can send pings back and forth. You wouldn't just disable the entire firewall. So we'll go back here and basically disable it as well. Go to the second one, disable it. And now if I actually do a ping, as you can see, it all gets through absolutely fine. And of course, do this final one for VNet C, and we should be good. So from VNet C, can we ping VNet B? Yes, we can as well. And from VNet B, can we get to VNet A? Yes, we can. And can we get to VNet C? Yes, we also can. So what we've proven so far is that if we set up these networks as we've described, we've proven that this works, and we've proven that this works. Now the question is, does the routing work? Can we do any transitive routing? Can we route through this middle part? So let's try to ping it. And as you can see, the ping is not working. And on C, let's see if we can ping A. And as you can see, this is also not working. So what we're going to have to do to get this working is we're going to have to make some changes to VNet B. So whereas it was previously just a Windows server, we're basically going to have to turn it into a proxy that can broker communications between VNet A and VNet C. So in here, this VM, we're going to have to do two things. First of all, we have to enable what's called IP forwarding on that. So IP forwarding is essentially that technique that we've discussed. Normally, when an address is sent and the address is sent over here, if this server or this network, I should say, is not the recipient of that address, right? So if I make a request for an address and this server does not know where the address is, it's nowhere here in this network or whatever, then it's normally just dropped. It just drops. But when you enable IP forwarding, if it can't find the server, it'll rebroadcast the request. to everybody in here, but also to any networks that it's connected to and everybody in here. That's why it's essential when you set up your peering relationship to allow forwarded traffic. This is not on by default for a reason because you may have a trust relationship between two VNets, and you may only want traffic that comes specifically from that VNet. We've seen this sort of thing already in the examples that I've given. If I have an enclave that I've set up, right? So this has my database and other super secure things that I don't want anyone to have access to. And I say that I peer with a network and I say, hey, I trust you and I'm going to peer with you so that you can actually access my environment, right? So you are allowed to hop in here and get information and then come right back, no problem. From in here, I may not want traffic that originated anywhere else. Because if I say when I create this peer relationship that I can allow traffic that was forwarded from this VNet, then that means that over here, if I have some type of rogue subnet here, I can initiate a request from here to this guy, and you don't have access to this subnet, but in this subnet, I put some kind of NVA, and then that NVA then routes the traffic in here. This scenario, this scenario right here, may not be ideal, right? You may not want something like that to happen, especially if you're trying to protect the resources that you are using. So, to prevent that, sometimes you may say, hey, do not allow forwarded traffic. I only want traffic that comes from here. And when you do that, no matter what you configure over here, it's not going to take any traffic that does not originate from inside of this network. Now, in our case, we of course want that to be the case. So we're going to have to set that up. And the first step in setting it up is as follows. So in order to do this, we have to go into the registry of your Windows box. And we're going to go to local machine, system, current control set. And then we're looking for services. And in there, we're going to scroll down to TCP/IP. Here we go. And then we're going to go in parameters. So what we're looking at then when we get here is this guy right here, IP enable router. So this essentially turns your Windows machine into a router and allows it to forward traffic along. So we set that to 1 to enable it. And after we do that, we need to restart the machine. And then we're just going to hit restart. So looks like that's restarted. So before we move forward, there's something else that we need to talk about that's a component of this, right? So all this while, we've been talking about creating multiple VMs inside of multiple VNets that allow for them to communicate with each other. And we are clear on the manner that this communication is going to happen. We're going to have VMs sitting in each of these. And this particular VM has been configured as an MVA by enabling port forwarding. So we're clear on that. And we know that these VNets have been peered. but this has not been peered at all. So when I make a request that says that I want 10.0.7.4, right? Take me to 10.0.7.4, or from over here, I make a request that says take me to 10.0.5.4. What actually happens? Why is making this request coming here? Is there some default capability that makes that happen, or how does that happen? Does that just happen naturally? Well, the answer is no, it doesn't happen naturally. Actually, what happens is that inside of every subnet, not a VNet, but a subnet, so inside of every subnet in Azure, you have the ability to create a document of sorts that represents how you want traffic to be routed. And this is referred to as a user defined route. So you can specify with a user defined route two things. You can specify rules associated with IP addresses that you're requesting to go to. So normally, as you saw, if I say, hey, take me to 10.0.7.4, it's going to look inside of here to see if it can find it. And it's going to look inside of here to see if it can find it. Somewhere in here, somewhere in here. Let's make this an arrow, right? So it's going to look somewhere in these places to see if it can find it, right? Now, if it can't find it in either here or here, right, in either A or B, then the route simply fails. It's done. It gets dropped. It's like it's not there. And that's the reason why we see that request timeout. You're not able to access it. Nothing is happening. Now, what you can do with Azure is you can use this user defined route to tell Azure, to tell the router what the next server it should go to along the path of routing is. So let's go ahead and let's create a user defined route. So they're called route tables. So create one, click on create. So this is going to route everything in A that matches that thing to B. Remember, it's not routing to the end destination. It's routing to your MVA or your middle server, right? It's routing to server B. That's where you want it to go. Now that the resource is created, let's go into the resource and we'll go over to the subnets and we're going to link it to the default subnet of VNet A. Okay, that's done. Now we're going to go into the routes and we're basically going to create one. And let's look at all these things here. So this is superfluous right here, the route name, it doesn't really matter. Call it whatever makes sense to you right here. The destination type, here you're picking whether or not you want it to be an IP address or there are some service tags and things like that. Like you can just say, hey, route to internet and things like that. Here over here is your next hop type. So the next hop type, again, you're going to specify what do you want the next hop to be. In this case, we want the next hop to be a virtual appliance. Right? Because we're going to be picking VMB as the next hop. Anything that matches the IP address or CIDR range that we're going to be specifying in a second, once we pick that we're looking for IP, will be sent to whatever address you specify here, whatever server that you specify here. So we'll give it a name. Destination type. And so you can see that once I picked that the destination type was IP address, now I'm now seeing the destination IP, right? So that means what is it that it's not the end. The destination is, you got to think about it a little bit different than normal. So when you're saying destination, you're saying what is the final destination of the IP address that you're routing. So in this case, the destination would be 10.0.7.4 if I'm on VM A, because that's where I'm going. That's where it's headed. So as you can see, I've entered in 10.0.7.0/28. So I'm saying that all 16 addresses going to that specific subnet address range, I want them routed to whatever is here, whatever is this place. And of course, you're going to see that we're going to put in the .6 IP address there. So you can put that in. All right, all set. Let's go ahead and let's add it. So now that we have that set up, let's go ahead and let's test it. So I'm going to try to ping it, and you should see that ping will still not work. And we know why it's not working thus far, because we haven't configured the routes. But if we do trace route to that address, you should see now that, yep, there you have it. It's actually showing the IP address of the MVA. It's showing the IP address of VMB. And it's really important to note that based on how we've configured this, these rules are specific to only the first 16 IP addresses in that VNet, right? Because we're using a /28. So if I were, for example, to put in .68 or some random IP address that's in that same subnet, in that same VNet, but not in the same subnet, right? Not in that address space. Notice that it's not going to respond back. So you're now getting request timeouts. And then conversely, I could put in any address that's inside of that range, and it will work for that address because it's inside of the range. And what it's all it's really doing is saying, hey, if you're in this range, I'm going to take you to this server. So now let's go ahead and let's go into VMB and let's add some of the rules that we need. So we're going to be opening up the Windows Firewall. Just close this. And then let's open up Windows Defender Firewall. And then we're going to go to Advanced. And then you should see here two kinds of things. There's inbound ports and there's outbound ports. So inbound ports, as the name implies, handles what kind of traffic you want coming in. You can control that from here. Outbound ports handle what kind of traffic you want leaving. For you to have a full network circuit, for you to be able to send a message somewhere and have the message come back like ping or trace route, all the servers along the way have to be open. So that means that not only do we have to enable inbound and outbound ports, but we also have to go over to the portal and create another user-defined route or route table that handles traffic coming from the other direction. So over here, we basically just create a new rule. We want it to be all ports and just allow all connections for now. Just call it forward all. Okay, so now let's create another route table. This one for the messages coming from uh, VNet C to VNet B, so the other end of it. As per our discussion, this would basically be needed for us to be able to complete a full circuit, to be able to do both the trace route and the ping. So I'm just gonna say a route C through B. Nothing special here, pretty straightforward. And that's created, so we can go to it and associate it first of all with the VNet C, the subnet in VNet C. There we go. And then let's create a route. And in this case, the route is basically going to be the opposite end. So it's all the same. But now the traffic we're looking for is traffic that is destined for 10.0.5.4. So anything that's going to this address, we want it forwarded to 10.0.6.4, which is our MVA. Okay, so we want it to be an IP address. Yep, and we're doing our /28. Next hop is going to be a virtual appliance, and that is the IP address of that appliance. Let's create that. So although we've enabled the port forwarding through the firewall on the VM itself, we've actually gone into the VM and changed it in the operating system. We have not done it at the cloud plane, which is meaning we have not done it in Azure. So you'll notice that in Azure, we have these items here, right? These are the actual NICs associated with the VMs that we're working with. And what we're going to have to do on the NIC for VMB is we have to enable port forwarding on it. So we can click in there, working. So we go to IP configurations, and then right there, you should see your ability to set the port forwarding. We can save that. The final thing you need to do now is you need to go in and modify the outbound rules. So far, we created the inbound rules and we created a rule that allowed for all traffic to go in, but we did not create a rule to allow for traffic to leave as specified. So let's go in and let's add that as well. And same thing, port, and we want all, and then we want to allow all. So you see how it blocks the connection by default? Just say forward all. Let's use a dash. There you go. And now, as you can see, when I do a ping, it's going through directly to it. And a trace route is also working from VNet C, no problemo. And does the ping work the same? Yes, the ping works the same. So we worked through the baseline. We created a network. We peered the network. We created VMs. We set up bastions. And then we worked on the cheap way, right? We set up IP forwarding in the registry on a VMB. We enable port forwarding for any in Windows Firewall. we created a UDR, and additionally, not mentioned here, but I'll just write it in, we enabled IP forwarding on the NIC card. That's a very important piece, because if that's not done, none of this is working and you'll be scratching your head. And then we also obviously did a ping test, and as you saw, we're able to ping back and forth with no issue. So now the pricey way, what we're going to do, we're basically going to set up an Azure firewall, right? Which is pretty straightforward to do, no big deal. We're going to add any rule on that firewall. This is the same kind of rule that we added in Windows, and I will give the same exact warning. Do not do this in a production environment, particularly if you're using Azure Firewall, because Azure Firewall has a public IP address, so it can be accessed from the open cloud. So make sure that when you're working with this, that you have consulted with your security office, and that whatever it is you're doing is in compliance with the line of business and the market vertical that you're in. You're not doing anything crazy. Next, we're going to update the UDRs. So right now, the UDRs are pointing to our NVA, our network virtual appliance that we've created. We're going to switch them over so that they are now pointing to the firewall. And then finally, we'll run ping tests just to make sure, so that you can see that everything is copacetic and functioning as it should, even though we've switched over. Before we can set up the firewall and configure a firewall, we have to make some updates to our subnet structure in the VNet that the firewall is going to be in order to enable it. So let's go ahead and let's go to VNet B. And we're going to go to subnets, and we're basically going to create a new subnet. And this we're going to call Azure Firewall Subnet. We're going to make it a 26. So that means we go to 64, we'll make it a 26, 26. Okay, so we'll save it. So now that that's saved, let's go ahead and let's create our firewall. And we're just going to call it, see, demonstration firewall. Set it as standard, use classic rules. So we're going to be using the existing VNet, and we're using VNet B. And we obviously have to have a public IP as stated, so be very careful with the firewall and what routes you leave as open. And that's basically it. So that's created now. So we can go to the resource, and we're going to be looking at the classic rules. We need the network configuration, add a new one. And over here, you can see what we're talking about. So it's pretty straightforward. You can provide it a name. Over here, you set the priority. You set the action, whether you want to allow or deny. You give the actual rule a name. The protocol that you want to specify, TCP/IP, UDP, you name it. The source type, where is it coming from? So it's an IP address or a service of some kind. The source itself, the IP address. So this can be a star, which is say anywhere. The destination type, again, is it an IP address? Is it a service tag? What is it? Is it a VNet? And then the destination address that you specify, and then the ports, and that can also be a star. And that's basically it. And you can go through and add as many of these rules as you want in order to allow whatever traffic you want to allow through your firewall or not. Firewalls by default are IP forwarders because that's essentially what they do. They block certain traffic and forward other traffic that you specify. So you don't have to do any further configuration on it beyond just specifying what the policies you want to use are. So we'll just call it any, the priority of 100. Okay, and we'll say any star, star, and then we don't care about the port, so star as well. And then we just save that. So while we're waiting, as you can see here, an IP address has already been specified for the firewall, right? And that's 10.0.6.68. Let's copy that, and then let's basically use it to update our UDRs. So go into our UDR here. We can just paste that there. That's kind of annoying. There we go. So that's good. It's updating the route. And then we can do C to B, and it's basically the same process. Okay, forgot that. So let's move that. There you go. All right, so it looks like the firewall has been updated as we expected, and user-defined routes have been created as we want. And we can see that if we look at the route table and the effective routes, we can see that the next hop is now pointing to 10.0.6.68. So it's not no longer pointing to our NVA, it's now pointing to Azure Firewall. So let's go ahead and let's run through the test to make sure that everything is working as it should. So we can do a ping, and it looks like the ping continues to work. And then we do a trace route, and as you can see, it's going to the new address that it's supposed to go to. Now let's try it from VMC. We do a ping, and the ping is working. We do a trace route, and it's going to the address that it's supposed to go to. That's basically it, guys. Setting up an MVA, and that's basically it, guys. Setting up an NVA and doing transitive routing is relatively straightforward, no matter how intimidating it seems. If you follow the steps in this video, you'll have no problems doing it for cloud native networks. Now, when we start talking about connecting between your on-prem environment and your cloud environment, it gets a little bit more sophisticated because now you're talking about BGP and other protocols that are used to advertise routes into your Azure network. That's a story for another day. And if you have those kind of problems, then you have my contact information below. Reach out to me. Let's talk about it. Let's see what we can do. Thank you for watching all the way to the end. If you enjoyed this video, please like, share, subscribe. We'll be having another giveaway. We're giving away another Lenovo Yoga Book 9i. We're giving away a Pixel Fold, and we have all kinds of cool tchotchkes that we're going to be giving away to all our loyal subscribers. All you need to do to be eligible is to send your comments to me on X, on email, or on LinkedIn, and be an active participant in the community by responding to polls that we provide and turning on alerts so that you can always get our content when it becomes available. Till our next video, happy coding and have a blessed day.